Good afternoon. Thank you for joining me today. I'm going to be talking about some odd things in JavaScript and variables that trip a lot of people up. First of all, my name is Julka. I'm a software engineer at AddThis. We're right in Tysons in Virginia. And if you're not familiar with us, AddThis does tools that people can add to their websites for social purposes. Things. All right, so AddThis works on social tools for websites. Is this good? The volume? Great. So our users will put some JavaScript on their page, and then when their page loads, we can load in share buttons to direct their visitors over to Facebook or Twitter and share their website over onto their social networks, and follow buttons, some related posts things, including a new tool which is a tip jar to gather donations. And we add all these in on JavaScript. So here are some of the things we're going to talk about in JavaScript today. We're going to talk about how scopes work in JavaScript, different types of functions in JavaScript, variable hoisting, closures, some odd things about arrays and objects, which is different from other variables in JavaScript, and a little bit of ES6. So first of all, a quick and easy way to play with JavaScript in your browser. In both Chrome and Firefox, you can open up developer tools and type JavaScript right in there. I'm going to have a bunch of examples in my slides if you want to follow along. On my first slide, we have a link to, wrong direction, to my slides. I also tweeted them out about an hour ago with the conference hashtag if you want to grab those and be able to use that code right away. All right, so scope. I think the best way to get into this is to see some real examples of what happens with variables in JavaScript and when scope starts to come in. So here's a really simple piece of code. We're naming a variable pink, and we're setting that value to 1. And then if we console log out the value in pink, we'd get out the value 1 there. What we also get when we do that is we've added in a variable to our window scope or our global scope called pink. So we can ask for window.pink, and there we'd get the value 1 again. Now, you might see a lot of JavaScript where you see var in front of a variable. And in this example, we'll set fuchsia to pink. I'd like to the number 2. And if we console log out fuchsia, we'll get 2. And then the same thing happens with window. If we console log out window.fuchsia, we get 2. All right, so now to create some instances where we're going to deal with scopes in JavaScript, I'm going to talk a little bit about immediately invoked anonymous functions in JavaScript. I'll get more into other kinds of functions later on. So here's a function in JavaScript. We'd replace that ... with whatever code we want to execute. Now I'll define this function and then immediately invoke it by putting those parentheses at the end. Surround the entire thing by parentheses again and put a semicolon in it. And this is an immediately executed anonymous function. It doesn't have a name. It's not available to us anywhere else, but the code in those ... gets executed right away. All right, so here I'm using that. So I have this immediately executed function, and inside there I'm setting magenta to the value 3. If I console log out magenta, I'll get 3. And if I console log out window.magenta, again, I get 3. I promise this will get more interesting soon. And then I can come out here outside of this function and console log out magenta, and I get 3. And then I've still got that window, and I can console log out window.magenta and get the value 3. I like the color pink, if you didn't notice. Let's see how long I can use these pink names. All right, so this is where things change a little. I'm now saying var rouge equals 4. All right, before I wasn't putting the var in front of there, and that var is going to be special for us. So here I can console log out rouge, and I get 4. But if I console log out window.rouge, I get undefined. This is because we are working in a new scope when we're inside these functions. And when we say var, when we create a variable for the first time or declare it, then we're saying that that variable is only available to us in that scope and child scopes of it. So the parent scope isn't going to have it. If I come back out of that function at the end of it and I console log out window.rouge, I'm going to get undefined. And if I console log out just rouge, I'm actually going to get an error that stops my JavaScript from continuing to run. If you pull down that sample code that has all of these, you might notice that you can't copy and paste the entire thing and put it into your console log. It won't all run because it'll stop at the first one of these major errors. But I included them in there so you can see the places where this breaks. All right, and now we're going to do some more of this. So here I have an anonymous function, and I'm going to define var blush equals 5. And then in my anonymous function, I have another anonymous function. And in here, I will console log out blush. And since I'm in a child scope of the one that defined var blush, I'm going to have var blush, and the value is going to be 5. I can then go on to change blush to 6 and console log out blush and get 6 again. I can also here define a var equals rows, console log out rows, and I get that 7 that I put in rows. When I come out of that function, I have some more console logs, and here I can console log blush. Now, blush is available to me in this scope. It's at the same indentation level, so it's in that same immediately invoked function. It's not nested in the second one. So when I console log out blush, I get that 6 that I set earlier. And I can console log out rows and get an undefined. And then if I come out of all of these functions and I try and console log these out, I will get 2 major errors that will stop my JavaScript from running because these aren't available to me at this scope at all. I've gone beyond where these were defined. All right. So here, just to illustrate, I can set my variable maroon and set it to 29. And if I console log it out here, I'll get 29. And I'll still have it available to me out here because I'm not inside of a function and I haven't created a new scope here. And if I console log it out here, I'll get a 29. And so when we work with modern JavaScript frameworks, what we're dealing with is function inside a function, inside a function, inside a function, and we have this indeterminate nest of scopes that can wreak a lot of havoc in what we're trying to do in JavaScript. And so these were anonymous functions, and here's some more anonymous functions that I'm throwing into variables, and the same kind of thing. I can have a variable grapefruit, which is a function, that has a variable raspberry, which is a function, and these all create child scopes, one within the next. All right, pop quiz. Can anyone tell me what I'd console log out here when I console log out Amber? Go ahead. Yes, great. All right, here's another one. So I have a var pumpkin, and it's going to define 2 functions, an orange and a tangerine, and then it's going to call orange. What would console log out if I call orange? That's the function that I'm going to execute. That's right. There's no console log in there. But now I'm setting pumpkin to 14. So what happens when I call tangerine and execute that function? Yes, 14. So at that point, I get a 14 console logged out. All right, here's another example. So I define 2 functions, ginger and paprika. And when I call ginger, I'm going to define window.peach equals 15, and then I can call paprika. So what console logs out, what do you think would console log out here with paprika? Yes, 15. I didn't tell you about this. So anywhere in your nested functions, you can call that window variable. That's sort of your global scope, and throw something in there, and it'll be available at all your different scopes. Now, this is something you want to do with care because you can end up with a lot of variables in there and might be using names that aren't unique, and other things on your page might care about what is in that window object. But it is a quick way to get something available everywhere. All right. How about this one? What do you think would console log out here when I ask for Mandarin? Yes, that was right, 18. Someone said 18. And how about down here? I hear some 16s. 17. All right, the room says 17. And there it is. There we've got 17. And then what about down here? Yep, the room says 16. Now what you might see here is we have a var Mandarin here, and then a var Mandarin here, and a var Mandarin here. So these are each different variables available in that scope. And when we do this with vanilla JavaScript, not in a framework, we don't get, once we say var Mandarin, we might not be able to get our parent scope's Mandarin because we're using our own. However, if it's you want to grab the Mandarin from your global scope, that would be available to you in window.mandarin. All right, how about this one? What do you think would console log out here? I hear some 19s. 20? Undefined. Someone said undefined. Someone's a JavaScript developer. This was a trick question. This is something I hadn't talked to you about yet. And that's variable hoisting in JavaScript. Another weird thing JavaScript does with variables. So when I say var terracotta equals 20, what actually happens is var terracotta gets hoisted to the top of that function, and var terracotta will be undefined. And then wherever I actually set the value of terracotta, terracotta equals 20 will stay. So this is the way the code actually executes. And when we call console log.terracotta here, we get an undefined. Which means that in this function, we don't get access to the parent's terracotta, even though we define our own terracotta later on in the code. And we already had some examples in here that used variable hoisting. So the one with the blush and rose had a var rose on the fourth line of its function. And what's actually happening there is right when that function executes, var rose gets defined as undefined. And then later on, rose gets set to 7. All right, closure. You might have heard people talking about JavaScript closure. And it sounds like something really, really fancy. But we've already looked at examples with closure. So closure is the idea that you have some functions and variables available in a separate area that you wouldn't have direct access to. So here's a simple example of that. I'd define a var marmalade, and that's going to be a function. And inside there, I can define var caret. Here, greater than 2. It increments var caret by 1. And then it returns a Boolean of whether or not caret is greater than 2. But this function returns the function greater than 2. So down here, I can say var salmon equals marmalade. So salmon now equals greater than 2. And the first time I console log out salmon, I'll get a false. The second time, I'll get a false. Third time, I'll get a true. So this caret variable still exists in there, but we don't have direct access to it outside of the anonymous function there that we're putting into the marmalade variable. And that's closure for JavaScript. That's it. You've got some stuff contained so that other things can't come in and touch it and access it directly. All right, arrays and objects. These are a little special in JavaScript. So in JavaScript, all of our variables are really objects. But we can have something that has the value yellow in it, and if we ask for the type, we get string. We can have 7, and the type of that is going to be number. We have Booleans, true and false, and the type of those is going to be Boolean. And then we have curly brackets, which are used to define objects, and square brackets, which are used to define arrays. Though if we ask for the type of an array, we'll get the answer object. If you want to know if something is an array, you ask array is array about that, and it'll give you a Boolean of true or false. Now, all of these variables in here, yellow, 7, true, the empty object, the empty array, these are all actually objects. So we can take that string yellow and put a dot length on it and find out the length of that string. So it's got all sorts of functions built in for functionality around the string yellow, but we don't generally treat it and talk about it as an object. Now, when we deal with objects and array objects, things get a little different. So here I have a variable var canary, and I'm going to say that it has a type of bird and that it flies, so flies is true. And then var bumblebee equals canary. Now, if I set bumblebee.type to insect and I console log canary.type, I'm going to get out insect. When we deal with objects and arrays in JavaScript and we copy one into another, we're actually copying a reference automatically. It doesn't work that way for strings or numbers or booleans, but when we deal with these objects, it happens like this. Now, if you're dealing with a JavaScript framework or some JavaScript libraries, they'll probably have a function in there to help you make a copy of an object. Or you can just Google it, and there's lots of different suggestions on ways to do this. Here's the same kind of thing with an array. So my array is var daffodil. It has the numbers 1, 2, 3. I take var dandelion and I copy daffodil, and I say it equals daffodil. I've copied the reference for it there. And if I push to dandelion, the number 4, and I console log out daffodil, I get 1, 2, 3, 4. Now, making a copy of an array is a little easier. You can just say daffodil.slice. Slice is a function on an array object. It takes 2 values, and it'll basically go into the array and find, so you might say 1 to 3, 1 comma 3, and it'll give you item 1 through 3 in that array. If you don't give it anything, it'll just give you the entire array, but it's a copy. And so here, I can dandelion push a 4, and if I console log out daffodil, I get 1, 2, 3. And if I console log out dandelion, I get 1, 2, 3, 4. There's quite a few functions in JavaScript for arrays just out of the box that'll make a copy for you if you need them. And your JavaScript framework or library might give you one as well. All right, ES6. So most of the stuff I've talked about today is ES5. That's ECMAScript 5. It's a standard for for instantiating programming languages, and we use it for JavaScript. ES6 is the new one, and it changes some things with scope. First of all, we're going to talk about 2 new ways of declaring variables in ES6. There's let and const. So instead of saying var, I can say let green equals 21, and then I can change the value on green and set it to 22. And this is very similar to var. We'll talk about some differences in a minute. I also have const. So I can say const sage equals 23, and then if I try and change sage to 24, I get an error because it's supposed to be a constant and it's not supposed to change. And so you've got these 2 options to better control when a variable shouldn't get changed by something else after you set it. Now this does something interesting with objects and arrays, since those are references instead of the actual another copy of it when we work with it. So I can say const lime and set that to an empty array, and then I can push an item into it. So here I'm pushing in the number 25. And if I console log that out, I get 25. I haven't gotten any errors. But if I say lime now equals a new array with the value 26, I'll get an error. So what we can't change here is the reference. We need to use the same reference for the object when we're dealing with an array or an object and the const declaration. But we can change what's in there. So here is an object. I do a const fern, and I give it the name of foo. And then I can also change that name to bar. I can give it a number of 27. And all of that doesn't cause any errors and changes the values. But as soon as I try and put a new object in there, even though the values are exactly the same, I'll get an error. All right, code blocks. This makes ES6 a little more fun. So before, we looked at an example like this. So I have a let olive equals 28, and if true, let olive equals 29. Here, I'll get a 29 and I won't get any errors. And if I come back out, I get a 28. So with ES6 and let and const, we end up using code blocks. So these kinds of curly brackets, even though it's very silly here with the true, each get their own kind of scope. And we can simplify this a bit. ES6 will let us just do that. Just some curly brackets to put something inside, and it has their own scope. It's really helpful when you're iterating over something so that you don't have to change the name of your variable every time, because if you're iterating through something, just to be extra safe. So I've definitely had some code that goes from I to J to K to L to M to N and just keeps going. And here that's not necessary, because we can just put it in those curly brackets and it's going to have its own scope. All right, and here's an example of that in a for loop. So I can say for and initiate my iterator. I'll say let emerald equal 30. And then I'll come in here and console log that out. After that, emerald ++ is going to run and increment emerald. And then it'll check to see if emerald is still smaller than or equal to 34. And it'll continue this on. And it'll console log out 30, 31, 32, 33, 34. Then it'll increment again, and it'll see that 35 is now not smaller than or equal to 34. But when I come back out and I ask for emerald, it hasn't been defined. Here's the same example with a var. So I do var emerald equals 30 instead, and I'll console log out through here again. And when I come back out, I get 35, because it ran through the loop one more time. It checked to see if emerald was now still smaller than or greater than 34, and it got a false. But that variable is still around. All right, two different kinds of functions in JavaScript. This first one is a named function. So we could say something like function pair, parentheses, define whatever inputs we want, whatever parameters we want, and then our curly brackets and the code that executes with that. Alternatively, we have anonymous functions. So we can say var pair or let pair or const pair equals function and then the curly brackets and whatever code we want. So the difference between these, with named functions, we're calling this a function declaration. It's added to your current scope. So if you're at your global scope level, you'll get it everywhere. If you're nested inside of a function somewhere, it's only going to be available to you there. And at lower scopes, it's hoisted and defined early. So that means that we can actually use this one recursively. And it's also useful for debugging, because if there's a function in there, if there's an error in there, it'll actually show the function name in the call stack when the error happens. And here's anonymous functions. So this is a function operator instead of a function declaration. It's available in whatever scope that variable you're putting it in is available. It doesn't add to the current scope if it's not put in a variable. So there's anonymous functions we were using where we didn't actually put it in anything. We just put it in its own parentheses. That doesn't affect, that doesn't put that function anywhere in your scope to messy things up. And that variable gets hoisted and declared, but it doesn't get defined until you get down to the part of the code where you actually put it there in the first place. And you can't call it unless you've defined it already. With the named variables, you can call it at any point in your code in that function, even if you've defined it at the bottom, which is what allows us to use it recursively. Right, so I've got an anonymous function here, but inside of it I have a named function. So I have a function shamrock that'll just console log out good luck, and when I call shamrock, I'll get console logged out good luck, but I won't have it available to me out here. And then similarly here, I'm just throwing this into another anonymous immediately executed function. So this is a child scope, and I've got access to Shamrock. It'll console log out good luck. And here's an example of the order not mattering. So I'm calling Shamrock, and then I'm defining Shamrock. And since this is getting hoisted up above this way, it's all right, and it works out exactly as you would want it to. And so here's an example of the recursion. I can define a varmint and have that equal a function Basil. And inside there, I can call Basil. But Basil, so console log out will show me that function, but console logging out Basil isn't going to be there. And this way, it lets me do some recursion in there. I could have also left off the varmint there and just used it as the variable Basil. All right, so why put functions in variables at all? And that's if you want to be tricky about the scope you're using them in. Because you can use a variable that's already available in one of your parent scopes and put that function in there, even though you're actually in a deeper one. So here I'll do a var jade, and I'm console logging out to the type of jade, and it's just undefined. And then in here, I'm actually defining my function jade. This will give me a variable jade, but only in this scope. And I can see that here I have type of jade as function. When I come back out, it's undefined. Whereas here, I can be a little more tricky. So I'll define my var turquoise and console log out the type. It's undefined right now. Go inside that function, and I can say turquoise equals function. And when I console log out the type of turquoise, I get function, but when I come back out, I also get function. So even though I'm in this completely separate scope, I can still reach out to my parent scope and use a variable that was set up there. All right, ES6 does give us another kind of variable, and for what we've talked about today, it basically works the same way, another way of declaring functions. It's a shorthand, so I can put my parameters there. No word function. That actually bugs me. I think functions should be called functions, but it saves you a bunch of characters. So here I'm going to take in the values x and y, and then I use these fat arrows, and I can immediately do the math or the operation that I want returned. So here I'm just going to multiply x by y, and that's going to get returned. So if I console log out cfoam23, I'll get the number 6. Really nice, quick way to just do some fairly simple manipulation on your inputs. This is how it looks like without any parameters. We still do the parentheses and the fat arrows. And then here, I don't have a value I want to return, or maybe I don't have a value that I can figure out in just one line that I want to return. So I will do curly brackets, and inside there I can put all my logic. In this example, I'm not actually returning anything. I'm just going to console log out pine as a tree. And then when I come down here, it'll console log out pine as a tree. So one exception here is these parentheses. If you only have one parameter that you're using for one of these functions, you don't have to use these parentheses. But if you're using 0 or more than 1, you need these parentheses. These fat arrow functions do make a difference for us in JavaScript when we're dealing with objects. And I'm not going to be talking to you about objects in this part of objects today, but basically inside of JavaScript objects, you have a this variable that has your variables from that object itself, and these functions will preserve that when you're nesting functions inside of functions. All right, so we've talked about scope and how those scopes are one within another inside of functions, and they bubble their way up. We talked a bit about different types of functions, anonymous functions as well as named functions, and anonymous functions that are immediately invoked. variable hoisting in JavaScript. So just because you put var on your 1000th line, var pink on your 1000th line doesn't mean var isn't actually getting set up on line 2. Closure in JavaScript, so how scopes help us hide functions and variables that we don't want used from the outside. Arrays and objects are special in JavaScript because we're always using them by reference. And then a little bit about ES6. I did want to leave you with a couple more resources. So developer.mozilla.org is actually a wiki that you can edit at any point if you find something in it that's wrong, but it is great JavaScript documentation that'll let you know how these functions work. Also, there is the second link is information about arrow functions specifically, and that'll go into more about how they're special in objects in ES6. And lastly, caniuse.com's information about ES6. So if you are only supporting the most modern browsers, you can use a lot of ES6 features already, but if you need to use older ones, then either you need to stay with ES5 or use some sort of in-between step that will compile your ES6 code down to something that will run in ES5 or even older ES6. All right, thank you for joining me today. I'll take questions if we have any. Yes, go ahead. No, I don't believe you can. So the question was, it made sense that you couldn't do recursion in a variable, in a function put into a variable, so in an anonymous function on itself, but could you do it mutual recursion back and forth between two? I don't believe you can, and that's going to be because one of them will get defined before the next one is, and you're probably going to run into an error in that. And JavaScript is going to care on those. You can still put it in a variable and make it a named function. So we had one example of that where I did, I don't remember what the colors were, but it was var foo equals bar parens. And then you had bar available as bar inside that function, and you could do recursion there and still have it in a variable. Yes? Say that again? I'm not sure about that. But you can get it with the named functions, absolutely. Yes?
Firefox X, I don't know whether it's ES5 or ES6 compatible, other than writing an EX6 expression and getting it to fail. How can I know?
All right, that's a great question. So one of the links on my slides is to can I use for ES6. If I go in here, I don't think I have internet access right now. So that will give me a table of compatibility, and it'll give you an idea of just how much of ES6 will work in the different ones. So it'll tell you that I think it's IE 11 and on, for example, or what versions of Firefox are good for that. And you can also click on that number to see more information. A lot of them will say a number like 12, and it might have only 12 things that they're checking for, or you might see a 10. It might still be green, but it's a 10 instead of a 12, so it supports 10 out of the 12 things that they're looking at. And that is a good resource for looking that up. Yes, it is still a thing. Absolutely. We, at AddThis, we support all the way back to, I think, IE 10 now. We just, in the last year, got rid of 8 and 9. So depending on how far back you need to go for the support of your site, you might want to be using feature detection. Anybody else? All right, thank you for spending time with me today.